Hey, thanks for joining me in the Science Zone lab. You like electricity? You know, we can't hardly live without electricity. Some people do. They live off of the grid, at least they live off of electricity that somebody's providing for them, but they are generating their own electricity. Well, you know, that word is interesting, electricity. Electricity and electron, do they have something in common? I think they do. In fact, in order to learn more about this, let's check this little model out right here. Now, you may have a toy like this at home. You remember the name of it? Yep, it's called a Hoberman sphere. Mr. Hoberman invented this little ball, and it's an expanding ball. And so I can open it up like so, and there we go. Cool. Now, this is going to represent an atom. You know, the atom is the building blocks of everything. Everything that you can see, touch, and feel is made of atoms. Even invisible things are made up of atoms. Mostly invisible. Atom is made up of mostly invisible stuff. Now, let's take, for instance, if this is the atom right here, what's in the center of the atom? Do you remember what's in the center of the atom? Well, it happens to be the what? It happens to be the nucleus, okay, is in the center of the atom. And when we have some particles, we're going to talk about just a few particles. And we have some electrons. Electrons all have a negative charge. Where are the electrons? They're in the outer shells, okay, of the atoms. Then we have protons, which are close to the nucleus, and the protons have a positive charge. The electrons have a negative charge. Then we have neutrons, and neutrons, they don't have any charge. It's like neutral. Put your bike in neutral, put your car in neutral, and you're not going to go anywhere. Well, so we start out with an atom, and we start out with electrons. Now, you know, you can carry electricity around with you. That's right. In fact, what I have in my hand right here, do you know what this is? Now, if you said battery, you're wrong. A lot of people call it a battery, but it's really not a battery. This is a cell. In fact, it's a C, this is actually a D cell. You can see the size is a D cell. And in fact, it has 1.5 volts. That's the voltage of a D cell. Now, I've got another one right here, and this is a what? This happens to be a double A cell. That's right, a double A cell, and it also has 1.5 volts in it. And what do you suppose this is right here? Did you say battery? Yeah. This is a battery, but these two things right here, these are called cells. So these two things here are cells, and this is the battery. What's the difference? Well, a battery has more than one cell in it. That's what makes it a battery. And this 9-volt battery, can you think about how many volts it has? That's right. The name implies 9, and it has 9 volts. And what's inside of one of these? Well, I took one of those apart right here, and you probably don't want to do that yourself, but I took one apart, and look what I found. I found 6 little tiny cells. That's right. This has 6 little tiny cells in it, and it made up this battery. And every cell, no matter what size is it, has 1.5 volts. So in order to get 9 volts, you have 6 1.5 volt cells. How cool is that? Well, inside of these batteries and these cells are electrons. If I happen to be a little electron and I'm in this little cell right here, all I have to do is electrons only travel in one direction. So the electrons can only go one way in direct current, and this is direct current. If you want electrons to go the other way, you're going to have to turn this cell around, and now the electrons can travel in the opposite direction. How cool is that? And that's what we call direct current. But in alternating current, like at your house or maybe where you go to school, when you plug things into that kind of current, it's not direct current, it's alternating current. And the electrons go backwards and forwards, very, very fast at the speed of light, about 186,000 miles per second or 300,000 kilometers per second. Whew, that is really, really fast. Now, if this little Hoberman sphere represents planet Earth, about how many times do you think the electrons, or how many times you think electricity or light can travel all the way around this sphere? About 7 times. Isn't that interesting? Because electricity travels at the speed of light. It's really, really fast. Well, let's take a look at some of this. You know, we can generate electricity right here in the lab. That's right, we can generate electricity right here in the lab. What I have in my hand right here is I have a coil. This is a coil of wire. This wire is very, very thin, and it's about the size of a very thick hair. And there's about 1/4 of a mile of that wire wrapped around this little core right here. And then on the end of it right here, on the end of those wires, I have 2 LED lights right here. And these LED lights are interesting, but we can generate electricity. If we can generate electricity, then these little lights ought to go on. And let's try it. Let's see what we got. In order to do that, what we're going to need is we're going to need a what? We're going to need some kind of a magnet. Okay, so I have some very, very strong magnets on the ends of this pipe right here. They're called neodymium magnets. They're very, very, very powerful. So all I have to do is I'm going to take and I'm going to put this magnet through that coil of wire. When I do, look at the LEDs. Whoa. And it's sticking to it. Whoa, it's sticking to it. I got it too close to there because there's some steel wiring on the end of it. If I push it through there, one light is going to light up. Did you see it light up? It's not very bright. And when I pull it back, the other light lights up. How cool is that? So if I keep going in and out of the coil, in and out of the coil, in and out of the coil, you might be able to see both of those lights lighting up. How cool is that? And that is generating our own electricity. There was a man that lived a long time ago. In fact, there's been a lot of men that's lived a long time ago. He told us how we could generate electricity. And his name was Michael Faraday. What a really, really smart man he was. But you know what? Who gives us our intelligence? You know that Jesus gives us our intelligence? So what do you think Jesus wants us to do with our intelligence? You think he just wants us to earn a lot of money and be famous and all the rest of that? Oh no. What he wants you and I to do with our intelligence is to serve him. And we need to tell others about Jesus' love for them. That's exactly right. So this is how we can generate some electricity, just by moving a magnet through a coil of wire. Or I can hold the magnet still and I can move the coil of wires. That's right. And we can generate electricity. That's how a generator works. Now, let's see what we can come up with right here. So there's a lot of things that may have generators in them. And you know what I have right here? I've got a little flashlight right here. This generator, there's a generator inside. There's no batteries, there's no cells in here. In fact, if you look very, very carefully, you might even be able to see a generator right here. And this is designed to take our hands and we take human muscle power and we're going to turn that generator. That's right. So we have a magnet right here. The magnet is spinning and we have 2 coils of wire right here. So when I make this go like this, I'm generating electricity, and let's see if it works. That's right. I can shine this right at you. There you go. How cool is that? Now, if I stop moving, that generator, if I stop moving that magnet, then we run out of electricity. How cool is that? Now, I've got another item right here. This is an emergency radio. Emergency radios are really good to have because in a case of emergency, you need communication. You need maybe to listen to the news, or maybe you need to listen to the weather station to find out what in the world is going on. But you know what? If you don't have a battery in your radio, it's not going to work. But this radio right here, this weather radio right here, you don't need a battery, although you could put a battery in here, but if you don't have a battery, it also has a generator in it. And it works similar to this little flashlight that we just showed you. So all we have to do then, there's a little antenna, we can put the antenna up right here, and there's a flashlight in here and also a radio. So let's see what we got. So I'm going to turn this. Let's go ahead and turn this on, and we might be able to get some sound out of this, although I don't know. I'm in my little laboratory, and the laboratory is kind of underground. We might not be able to pick up much. Let's see what we get right here. Well, I'm not hearing radio. Let's see if we can generate some electricity to make a little light go on. Let's check this out. Let's see. Hang on. And I can't do that either. But there's our little radio. Let's see what we got right here. This is AM and FM, and we got a turning little jobby right. Let's check that out. Well, I can't get anything to work at right now, but we're going to put this away. Let's check something else out. Let's see what we got. First of all, Oh, this is interesting. This is called a what? This is one of those shake lights. You know, a shake light works the same way as this little light right here, this little flashlight right here. Because there's a coil of wire. See the coil of wire right there? There's a coil of wire. Look at that shiny thing right there. That shiny thing is a very, very strong magnet. And if I shake the light back and forth, let's shake it back and forth. Can you see that magnet going back and forth? And it goes through the coil of wire, back and forth, through the coil, back and forth, through the coil. And what it does is it can light up a light bulb every time that goes through there. And I'm going to go ahead and shake it up and down, up and down, up and down, and back and forth, and you can see that we're generating electricity. Isn't that cool? That's a very, very cool light. Doesn't need a battery, doesn't need a cell, because it has its own generator by taking a magnet, putting it through a coil of wire. How cool is that? Now, there's another way of generating electricity that I think is pretty cool. You know, we can generate electricity by using something very, very cold and something pretty hot. That's what we can do. So what I have right here is I've got something pretty cold. I've got a little container right here, and that container has ice cubes in it. You can see the ice cubes in there. Can you see the ice cubes? Here we go. Let me pull some of those out here so that you can see them. So we have some ice cubes in there, right? And then we're going to need some very, very hot water. Okay, so I've got some hot water over here. And let's see what we got. I'm going to pour some hot water, okay, in this little container right here. And let's see. It looks like it's hot. It feels like it's hot. Oh, can you see some condensation coming up over here? A lot of people call that steam, but technically speaking, it's condensation. How cool. I'm going to put this back over there, all right? Thank you, Miss Deborah, getting it out of my way. Now, in order to generate electricity by using something hot and something cold, we're going to need a very, very special thing. And I have it in my hand right here. In fact, it looks like a little windmill right here, but these little straws, they are connected to a little generator right there. It's a little tiny generator, or a motor. It's actually a motor in this case right here. And there's two legs on it. There's one leg right here. There's the right leg, and here's a left leg over here. Now all we have to do is we're going to get this leg right here. We're going to put it right in our cold water, our ice water. This other leg, we're going to put it in the really, really hot water. Now, in the middle of this right here, if you can see, there's a little piece of white thing right here, and that is a thermoelectric converter. And so this is called a thermoelectric generator, and all we have to do is get one leg really, really cold and the other leg really, really hot. So I'm going to put it down inside of here. Now, as soon as this leg gets really, really cold and this one gets really, really hot, and those two legs are made out of aluminum. Now, aluminum is a pretty good conductor of heat and cold, and so it's going to get pretty hot and pretty cold. And you might be able to see that in about a minute or so, then the little tiny straw blade right here in a little fan, it's going to start to turn. And when it starts to turn, then we're going to look, oh, it's starting to turn right now. What direction was it starting to turn? It was starting to turn that way, didn't it? And that's what we call what? That's what we call counterclockwise. And there it goes. There it goes. There's no battery. There's no cell. And it almost looks like it's magic. Of course, it's not magic at all. It's science, because we're generating electricity. So the little motor is going this way. The electrons are moving that way. And that's what we call counterclockwise. Now here's a problem for us to solve. Do you like solving problems with science? Oh, I do. It's interesting. So let's use our brain a little bit. Now if we want the electrons to go the other way, to make this little fan, this little straw fan, to turn the opposite direction, we're going to have to get those electrons to turn the other way. How can we get those electrons to turn the other way? What can we do? Did you say switch the hot and the cold? Did you just switch them around? Okay, let's try to switch them around. Let's switch them around like this. There you go. Now what direction is that fan that little straw going? Well, it's going this way, but it's still going the same direction. I just turned everything around. So what's a better way of doing that? Just take the hot and move it where the cold was, Hey, that's a great idea. So I'm going to take it out like this, okay? And I'm going to take the hot one and I'm going to change it to where the cold is or was. Okay, let's put it down right here. Now we're going to have to watch this carefully. As soon as that hot leg gets cold, because I put it in the ice water, and as soon as the cold leg gets hot, because I put that one in the very, very hot water, then we're going to do what? The electrons are going to stop. We're not going to have a flow of electrons, and that's what happened. Our little straw fan stopped. It stopped. Now, as soon as the hot leg gets cold and the cold leg gets hot enough, then we're going to have a flow of electrons, but they're going to be going in the opposite direction. So look very carefully, and it may take a few seconds for this to move, but oh, and it started to move. Did you see it? Moved about 1 millimeter, okay, but it's going to start to move even faster right here. Just have to wait on it, and that's going to go what we call clockwise. It moves some more. It's going to go clockwise, and it's going to go clockwise, and it will stay spinning. There it goes. And it will stay spinning for as long as the hot stays hot enough and the cold stays cold enough. Isn't that interesting? So we can absolutely generate electricity by using something very, very hot and something very, very cold. So if you build a house someplace where you had a hot spring and a nice cool creek nearby, hey, you've got hot and cold. That's very interesting. Well, hey, I'm going to move this over here a little bit out of our way. Let's talk about electrical safety. You know, we have to be careful around electricity because electricity that's natural in your body, you don't want to confuse that electricity by using some kind of outside electricity environment. So you never use electricity or use anything that has electricity when your body's wet. When your hands are wet, your feet are wet, you're in the hot tub or the swimming pool, the bathtub, never use something that you have to plug in. So I have a little plug-in item right here, and this happens to be a light bulb, and it's in this little connector right here. And the two wires that come from the wall, these are the ends of these two wires. This light bulb will not light unless those two wires are touched or are connected. All right, so let's see if the light bulb works. All right, we're going to find out if electricity and water is a good combination. Okay, so I'm going to put a little glove on right here. All right, and I'm going to have Miss Deborah plug that in for us. Okay, and we're going to find out if there's any electricity coming from the cord to the light bulb. What I have right here is I have a pair of scissors, and the scissors are going to connect those two wires together, because I'm going to put it down on the table like this, and I'm going to put that on here, and oh, look at there. Yes, so we do have electricity going through those two wires. Okay, now we're going to go ahead and unplug that, and we're going to find out what happens when electricity and water meets. So I have some water in this little cup right here. I'm going to put it down right here, okay? And then I'm going to have Miss Deborah plug that in. Okay, here we go. Now we have water and we have electricity. Do you think the light bulb is going to go on? Are we going to get a light? Well, let's find out. I'm going to put it down in here like this. And what happens? There's no light at all. Isn't that puzzling? It really is, because there's electricity in those two wires, and if water and electricity aren't supposed to meet, we should be having a light right there, but there's no light. Well, I'll tell you what the deal is. Well, what the difference is this right here. You and I are the water in our body, because we're about 70% water. The water in our body is not like this water coming out of your faucet. No, not at all. Because the water in our body has what? It's got a lot of minerals in it. And those minerals absolutely make water conductive to electricity. It'll allow electricity to flow in it. So here we go. I've got this stuff right here that you may have at home. What is it? It's salt. That's right. So I'm going to sprinkle a little bit of salt in this cup right here. So we're going to add some mineral, because salt is what? It's sodium chloride, and it's a mineral. And you and I have lots of minerals in our body. I'm going to take this little pair of scissors. We're going to mix that up right here. Okay, now what do you suppose is going to happen when we plug our light bulb in. Is the light bulb going to go on or not? Okay, so Miss Deborah has plugged this in. And remember, there's electricity going through those two wires. I'm going to put it right down in the water, and let's see what happens. Whoa, the light bulb does go on. Wow, that's why it's so dangerous for you and I to be operating anything when our body's wet. If your hands are wet, if your feet are wet, if you're in the bathtub, the swimming pool, whatever, you don't want to touch anything that has electricity going through it. Because why? Because the water in our body, it has a lot of minerals in it, and it will conduct electricity, and you can be shocked. You can be electrocuted. You could die because you weren't very safe around electricity. Well, let's see. I'm going to have Miss Deborah unplug that so we don't have to worry about the electricity anymore, and we'll take this out of there. Now, that is interesting to me. So, you know, what's interesting to me is this. You know that Jesus has created our human body. Our human body is so magnificent. He created the human body so that it can generate its own electricity. How do we get the energy that we need in order to generate that electricity? Well, we get it from the food that we eat. And Jesus has provided, and he has created an abundance of different varieties of food so that you and I can eat. And our body will take all of this nutrition in, and we can have a healthy body. Because, you know, Jesus wants us to have a healthy body. So I want you to be reminded of that. And I want you to be very, very safe around electricity. And I think we learned a lot today about electricity. I am sure glad that you and I can be safe around electricity. And thanks for joining me in the Science Zone Lab.